Alright, welcome. In this video, we're going to be talking about the quadratic formula. And in this video, I'm just going to give you the formula. I'll tell you that the quadratic formula is that if ax squared plus bx plus c is equal to 0, then x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Kind of like you learned in Algebra 1. Okay, and I'm not going to be proving that for you in this video. If you are interested in getting the proof of this, then you should probably click, about right up there because I have a video of that and you could, see the proof there. Okay, for now we're just going to say that we can use the complete the square algorithm to prove the quadratic formula, and we're just going to leave it at that. Okay. So first we're going to talk about the discriminant. If that's the thing on the inside of the square root of the quadratic equation. The quadratic formula, pardon me. And, well, we know that the square root of a negative number doesn't really exist. Okay, it's not a real number. And so we're going to take that and, use that to help us decide how many solutions a given equation has. Okay, two solutions, that's going to be where b squared minus 4ac is a positive number. Okay, and to draw you a picture of what that might look like, okay, you've got an x-axis, something like that, right? We've got two x-intercepts, okay? Because, now, and this is important, I definitely didn't emphasize this at the beginning, this quadratic formula, it only works when we've got it set equal to 0. Okay, we need a secondary equation, and we need it set equal to 0 in order to use this. Okay, and then the reason that the positive inside the square root is going to give us two solutions is that plus or minus. The plus will give us one solution, the minus will give us another, because we're adding a positive number and then subtracting a positive number, giving us two completely different x values. No solution is going to be where b squared minus 4ac comes back negative, because we know that taking the square root of a negative number is not going to give us a real number. Okay, and so what that would look like is, like there are other versions of these where the parabolas are upside down, but it would look like that. There's no x-intercepts. Okay, and that would be because you are taking negative b plus or minus something that isn't a real number, so we don't have any real number solutions. Okay, and then one solution, okay, I'm going to draw that one for you first. Okay, that's going to be where we have an x-intercept, but it's on the vertex. And so it's really just one point where we're hitting the x-axis. And this is going to happen when b squared minus 4ac is equal to 0. Okay, now if we're thinking about it, back to the formula over here, if b squared minus 4ac equals 0, we know the square root of 0 is 0. So negative b plus or minus 0, okay, adding 0, subtracting 0 doesn't change anything. So we're going to get the same solution twice. But I think we'll see that happen a couple of times in this video. All right, so now let's work some examples that have to do with the discriminant. Okay. So the first is determine the number of real solutions to the equation. Okay, we can do this. So we're going to use b squared minus 4ac. We're going to analyze, is it positive, is it negative, is it 0, and then we'll, make our conclusion based on that. So over here, okay, my a equals 1, b is going to equal positive 8, and c is going to equal negative 3. Okay. So when I go in here and I do b squared minus 4ac, that's going to be b squared is 64. Minus 4 times 1 times negative 3. So 64 plus 12. And that's going to be greater than 0. So I can conclude that this has two real solutions. And then 9x squared plus 1 equals 6x. This is not set equal to 0. We have to first set this thing equal to 0. Okay, so that's very important. Okay, so I'm going to say set to 0. Okay. So 9x squared plus 1, I'm going to have to subtract 6x from both sides to get this set equal to 0. So 9x squared minus 6x plus 1 is equal to 0. Okay, so I know that I've got a equaling positive 9, b equaling negative 6, and c equaling 1. Okay, I'm going to do b squared minus 4ac. And that's going to equal b squared is negative 6 times negative 6 is positive 36, minus 4 times 9 times 1, hey, that's also 36, so that's going to equal 0. Okay, and if the discriminant is equal to 0, okay, we just said that's going to be equivalent to one real solution. Now, the next three are, actually the next six are pretty much the same. Okay, so solutions to the equation, or x-intercepts of the graph, we're going to start by setting these things equal to 0 anyway. So it's really the same idea. So I think now would be a good time for you to try the next six on your own to make sure you're doing it right. And you can check your work against mine, which is going to just pop up here in a few seconds. Okay, so if you're going to do that, you should pause now. All right, there you go. There they are, or at least three of them. Okay, so I went through and I did, labeled my a, b, and c, checked the sign of b squared minus 4ac. I got one that was equal to 0, one that was less than 0, one that was greater than 0. Those kind of like broke out into our three cases, and okay, I'm happy. Now, number 4, 5, and 6, I think I said it, but I didn't really show it or anything. So I'm going to jump in, I'm going to do one of these, and then I'll just, have you do the other two, kind of like usual. So let's scroll up here. Okay, then x-intercept, okay, that's a place where y equals 0. Or maybe, yeah, okay, these are all written, oh no, but that last one is f of x, okay? So y equals 0 or f of x equals 0. So what I'm going to do is I'm going to say, okay, it's the number of solutions to the equation 0 equals negative x squared plus x minus 6. So I can use the quadratic formula, the discriminant property, like all that good stuff. Okay? So I'm going to label my a, b, and c. A equals negative 1, b equals positive 1, c equals negative 6. We've got b squared minus 4 times a times c equals 1 squared minus 4 times negative 1 times negative 6. Okay, so that's going to be 1 minus positive 24. Okay, so that's going to be a negative number. And since b squared minus 4ac is negative, I'm going to say this equation had no solution, no real solution, so it has no x-intercepts. Right. Now, let me shrink this down a little bit, give myself a little bit more room to work on the others. And now you should try the others on your own and check your work against mine, which is going to pop up here in a few seconds, so you should probably pause now. Okay, there they are. So we had kind of one of each variety, one no x-intercepts, one with 2, and one with 1. Okay, the only thing that I would like to add to these number 5 and number 6 is that I think both of them are factorable, right? So I would kind of point out that, on a factoring level, what's common to x squared and negative x? Well, that x. So I'm going to factor out the x and think, what would I multiply x by to get x squared minus x? And that would be x minus 1. Okay? And then we know that x-intercepts are 0. And we see that we're getting two different ones because I've got two distinct factors that both have zeros. X can equal 0 and x minus 1 can equal 0. Okay, and then on the right, this is also factorable because I was thinking, I know two numbers that multiply to 36 and add to 12 and be 6 and 6. Okay, so y equals x plus 6 times x plus 6. And that's why we're seeing just one x-intercept here, right? Because if we set this thing equal to 0, this is just going to lead us to the same solution twice, right? We're going to see that if x is negative 6, then y comes back 0. Okay, but because there's only one solution to that, we know there's only one x-intercept. So I think that's all I'm going to say about that. Right, now here's one that we're going to use quadratic formula to solve. But what I'm going to say is that I'm looking at this one, I'm pretty sure, oh yeah, this is definitely factorable. Okay, I can use negative 2 and negative 3, right? Numbers that multiply to, and I think I'll do that afterwards. You take 2 and 3 and you multiply those numbers, and that's what your two numbers have to multiply to, so that m times n needs to equal 6. And then m plus n, those two special numbers, they need to add to negative 5. So I know that, one of them is going to be negative 3 and the other one's going to be negative 2. Okay, but I'll come back on that a little bit later. Because right now, this is a video about the quadratic formula. I'm going to use a quadratic formula, but I'm also going to tie it into what we already know. So I'm over here, and I'm going to say, so quadratic formula, a equals 2, b equals negative 5, and c equals 3. And if you're having trouble, remembering or memorizing the quadratic formula, what you're going to need to do is write it down a bunch of times, right? Say it out loud. So when you're going and doing the homework, or when you're doing these practice problems, you should try to remember it, write it down as best you can, and then go check against your notes, right? It's just a couple of pages previous, right? And you have it right there on your notes book. So we know if we've got the thing set to 0, x equals negative b plus or minus the square root of b squared minus 4ac. all over 2a. Okay? And that's why you'll see me every time I will write out the formula if I'm going to use it, because I'm trying to show y'all that the best way to remember something is to just use it a bunch of times. Say it out loud, write it down in your own handwriting. Okay, so let's plug in some numbers. X equals negative b, so it'd be positive 5 plus or minus the square root. B squared is 25 minus 4 times 2 times 3, 4ac. Okay, 8 times 3 is 24. Oh, that's very convenient. All over 2a is 2 times 2, and that's going to be 4. So I've got, okay, 25 minus 24 inside the square root, so that's the square root of 1. And we know the square root of 1 is 1. So I've got 5 plus or minus 1 divided by 4. Okay, so x could be 5 plus 1 is 6 over 4, which is 3 halves. Or maybe x could equal 5 minus 1 is 4 over 4, which is 1. Okay. Now we can use quadratic formula for this. That's great. But now I'm going to show you how we would solve this with factoring. Right? Just remind you of something that we talked about. Maybe I think that was the last lesson. So what I'm going to do is I'm going to split up the negative 5x into negative 2x and negative 3x, and I'm going to kind of use my judgment to say which one I should use. I'm going to put the 2's together, but you can do it the other way if you want. Minus 3x plus 3, and that's going to equal 0. Right, so I took this negative 5x and I split it up into negative 2x minus 3x. And then I'm going to think about the first two things. You know, what's in common on those? That's the 2x. And then what I'd be left over if I factored out a 2x would be x and a minus 1. And then these two things, what do they have in common to them? Pretty much just a 3, but I know that I'm going for an x minus 1 because I want this thing to be the same on my second thing. So I'm going to factor out, I think, a negative 3, right? Yeah, and then that'll leave me with an x and a minus 1. Okay, and those things, they all multiply together equal 0. Now I'm going to factor out the x minus 1. And now I think I've gone far enough to where you can see how x equals 1 and x equals 3 halves are going to solve this equation as well using factoring. I think that'll be enough of that. Right, now here's 4 you can try on your own. Okay, now what I'll say is that if you look at one and you're saying, like, wait a second, that thing's factorable, solve it with factoring, right? I'm going to use the quadratic formula in all 4 of these because that's what's new to us. Okay, now remember, you got to start by setting all these things equal to 0. But I would really like for you to try these on your own. And, you know, if you're going to do that, then you can check your work against mine, and you can see those answers pop up in like 5 to 10 seconds. Okay, so you should pause now. All right, there they are. Oh, I forgot to box my answer on this third one. All right, there we go. Okay, I worked all 4 of them pretty much the exact same way. Just kind of plugged in the numbers and chugged along and got myself an answer. One thing I was going to point out is that we haven't really studied radicals in this class, so you won't be expected to simplify things like the square root of 88 yet. I mean, later on in the course, absolutely. That's a very Algebra 2 thing to do. But for now, we'd be good to just stop at negative 2 plus the square root of 88 divided by negative 6, or negative 2 minus the square root of 88 divided by negative 6. We didn't have any in this selection that came back no solution, but as soon as you saw that you were trying to take the square root of a negative number, that's when you would kind of throw your hands up and say, hey, this equation has no real solution, I'm done working. All right, now to wrap up, we've got some equations, I think there's 4 or 5 of them, where we're going to solve it using any method, and we're going to explain our choice of method. Now, I'm just going to remind you that you always have the freedom to use whatever method you feel like using in my class. You're never going to say, hey, you have to solve this with complete the square, you have to solve this with the quadratic formula, or you have to solve this with factoring. There are going to be certain equations that are best solved with one or the other, or something else. Okay, but for these, you know, all of them, we got to start by setting equal to 0. So I'm going to start with that. Set this equation to 0. So I've got x squared minus 10x minus 1 equals 0. And pretty much my idea, my taxonomy is, okay, we've got a quadratic. And it's either factorable, or I can figure out how to factor it, or I can't. I'm going to say I can factor, because it's not even if it's factorable or not. It's whether I can or cannot factor it. Okay? Or I can't. I am not able to factor. If I can factor, I'm going to solve by factoring. Every time. Oh no. I'm going to solve by factoring. And if I can't factor, every time I'm going to use the quadratic formula. I think that's the way to go. You could also complete the square, but I'm really recommending that you find it in yourself to just memorize the formula. Quadratic formula. Okay, so that's kind of like my thought process here. Okay, I'm looking at this. I'm not thinking of any factors of -1 that add to -10. That doesn't seem very realistic, so I'm going to have to use the quadratic formula. But I know that x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and I'm just going to plug in on that. -b is positive 10 plus or minus the square root b squared minus 4 times a times c, so minus 4 times 1 times -1. This would be the square root of 104, and I don't really know anything. That's not a square number, so I'm not going to be able to do anything with it. All over 2a is 2. So I'm going to say that yeah, 10 plus or minus the square root of 104, all divided by 2. And, I chose the quadratic formula method because I couldn't factor. 2x squared minus 13x minus 24 is going to be equal to 0. All right, let me think about this for a second. Is this factorable? Yes, it is. Okay, so I'm looking for two numbers that multiply to 2 times -12. So I want two numbers m and n, where m times n is -48. And m plus n, okay, their sum comes back -13. Okay, so I'm thinking about this. 48, 12 times 4, 24 times 2. But there's another one that people frequently forget about, and that would be 16 times 3. Okay, 16 times 3 is 48. So if I had m equals -16 and n equaling +3, okay, those two numbers would add together to -13, and they would multiply together to be -48. So what I'm going to do is I'm going to take the -13x and write it as -16x plus 3x. Now that I've split up the middle term, it's ready to factor with group and factor. So I'm going to look at 2x squared and -16x, and I'm going to say, what's in common to both of those? That's going to be, well, x in both of them, and the 2, because 2 and 16 are both even numbers. So I can factor out this 2x, and I'll be left with an x and a -8. And then what's common to 3x and -24? I think just that 3, because 3 divides 24, so I could say that's going to be x. Oh, and another -8, so that's a good sign. No, that would not be good. We have a 0 product property, not an 8 product property. So I'm going to factor out that x minus 8. I'll have a 2x plus 3 from that. Okay, those things are multiplying together to equal 0. And, okay, if those two things are multiplying together to equal 0, one of them has to be equal to 0. So either x minus 8 is equal to 0, or maybe 2x plus 3 is equal to 0. Okay, so I would get x equals 8, or maybe 2x equals -3, which would be x equals -3/2. Okay, so I got two solutions by factoring, because I was able to factor. But what I would add to that is that if you didn't see those factors coming, you could have used the quadratic formula as well. Just the numbers might have been a little big. All right, now the next two I think you should try on your own. Okay, so go ahead and do those and check your answers against mine, which are going to just be popping up the screen, 5-10 seconds. Okay, so you should definitely pause now. All right, there you go. That was actually a technique I'd forgotten about, the direct solved technique. Okay, so the first one was factorable. 13, it was factorable. I feel like I lost a number in here. It might have been when I deleted one of the problems that renumbered, but no matter. Okay, I used factoring because I can. If I can see it as factorable, I'm going to solve it with factoring every time, personally. And then number 14, it was I was able to direct solve this because there was no b term. Okay, so if that happens, we can oftentimes just kind of add the c over to the other side, divide by a. Okay, so that's where I got x squared equals 25, took the square root of both sides, got x equals 5 or -5. All right, I think that's going to be that's all the examples I got for you today for this video. So I'm just going to say thanks for watching.